this video, I give an intuitive justification for why a monopoly prices on the elastic portion of the demand curve. Now, the first step to establishing this fact is to recognize that a monopoly sets marginal revenue equal to marginal cost, and that marginal cost is going to be greater than zero. That means that marginal revenue is going to be positive, and if we were going to look for a place where a monopoly actually ends up pricing on the demand curve, that's going to be a place where marginal revenue is positive. So let's take a look at some graphs. This is the second step. Take a look at some graphs and see where it is more likely that marginal revenue is positive. If we take a look at this graph, if this is an increment in the quantity of 1, this is going to be the gain in revenue, and this is going to be the loss. Similarly, over here on this graph, here on the right-hand side, the gain is going to be this small red area, and the loss will be this big black area. Clearly over here, marginal revenue is more likely to be negative, and over here it's more likely to be positive. This gives us another motivation for why monopolies raise prices and restrict quantities, because we're more likely to be up this direction on the demand curve, where the black area is actually going to be smaller than the red area. So that's what we're going to be looking for, is a spot where the black area is smaller than the red area. So how does this relate to an elasticity? Well, we can take the formula for elasticity and break it down in a way that maps to this graph and these areas, which are color-coded for your convenience. Now, the elasticity of demand formula is percentage change in quantity over percentage change in price. Now, what that means is if we break this down into each of its components, what we'll see is that this is delta Q, the change in quantity, over the change in price over price. We can go ahead and invert and multiply, get just one fraction bar there. And what we'll see is that this is delta Q times P over delta P times Q. Now, it's important to recognize where delta Q and delta P and Q and P are on this graph. Now notice that the change in the price is going to be right here. That's going to be delta P. And the quantity is going to be right there. So that's going to be Q. And what we'll see is that this black area corresponds to delta P times Q. Similarly, if we were to look here at the red area, this red area is going to correspond to delta Q as its width, and then we're going to have P as its height. Just base times height, and that's going to be the area of this rectangle. And so we're looking for a place where the monopolist's marginal revenue is bigger than zero. In other words, we're looking for a place where P times delta Q is bigger in magnitude than delta P times Q. What we'll look at over here is up in this formula. What that means is that we're looking for a spot where delta Q times P, which is in the numerator, is bigger than P times Q, which is in the denominator. What that means is that this is bigger than that, and as a ratio, that means that this is bigger than 1 in absolute magnitude. So bigger than 1 means that we're on the elastic portion of the demand curve. Now technically one of these deltas, Q or P, is going to be negative, and so this will mean that we'll actually have bigger than 1 in magnitude, but less than negative 1. But this argument establishes that we end up on the elastic portion of the demand curve when we're considering the monopoly's pricing problem.